Another popular natural language processing technique is called topic modeling. Let's go through an example. Let's say you work for a legal firm and you're working with a company where there's some money that's been embezzled. And you know there's some key information lying in the emails that have been sent around the company. So you go through the emails and there are hundreds of thousands of emails. So what you need to do is you need to figure out which ones are related to money versus other topics. So what you can do is you can apply labels to all those emails. For example, some of these emails are about projects, some of them deal with money, and some of them are personal emails. So you can either hand label them based on what you read in the text, which would take a long time, or you could use a technique called topic modeling to find out what these labels are and automatically label all these emails. And that's what we're going to be going through in detail in this next section. For topic modeling, the input is a document term matrix. As I said in an earlier video, a document term matrix is a matrix where the rows are different documents and then the columns are different terms. And the values in the matrix are the word counts. So what's going to happen is each topic will consist of a set of words, and in this case, order doesn't matter. So we're going to work with the bag of words format that I talked about earlier. Basically, you have a bag and you throw in a bunch of words, and the order of those words don't matter. So each topic is just going to be a bag of words. The way we're going to apply topic modeling is by using a Python library called GenSim. So GenSim was created to do topic modeling along with some other NLP techniques. And one of the topic modeling techniques that's really popular is called Latent Dirichlet Allocation, and that's what we're going to be talking about in this next section. And then the output of topic modeling is to find various topics throughout all the text. And if you've been following along this tutorial, what I'm trying to do is I'm looking at different comedy routines, and then what I'd like to see is for every comedy routine, what are the different topics that the comedians are talking about. So what I'm going to see at the end is what are all the topics that the comedians are talking about, and then for each comedian, what are the topics they talk about. Again, the technique that I'm going to be talking about is called Latent Dirichlet Allocation. There are a couple parts to this term right here, or this phrase right here. The first is latent, which is another word for hidden. So what we're trying to do is we have all this text, and we're trying to find the hidden topics in there. And then Dirichlet is a type of probability distribution. So I'm going to leave it at that for now. I'm going to go into more about probability distributions and how they relate to LDA in a few slides. Okay, so how does latent Dirichlet allocation work? Well, let's say I had these 5 documents right here, right? If you take a look at them for a second, you'll see some of them are about fruit, some of them are about pets, and so on. So if I were to take this corpus, so this collection of documents, and I applied LDA on it, then what would happen is I would get this as an output. I would see that the first document is 100% about topic A, and then the next 2 are about topic B, and the final one is mix of A and B. And so that's what the machine does for me. And then my job as the user is to figure out, okay, what do topic A and topic B actually represent? If I take a look at those topics in detail, you can tell that topic A is about food and topic B is about animals. And so then you can go back and then you see now I started with these 5 documents and I've used LDA to automatically label them with these 2 topics. All right, so that was a simple example of LDA. Well, let's talk about this in a little bit more detail. So LDA, as I mentioned earlier, is all about probability distributions. And probability distribution is a more complex way of saying a mix of different things. So on the left here, I say that every document consists of a mix of topics. Another way to say this in more technical terms is every document is a probability distribution of topics. So what does that mean? Well, you see every document here is split among a couple different topics. So you'll see for the first document, it's 100% topic A, and that last document, it's a mix or distribution of different topics. On the right here, you'll see that every topic is a probability distribution of words. An easier way to say that is every topic is a mix of words. So you'll see the topic at the top there. Those are all the words that are in our whole collection or our whole corpus of documents. And you can see that within the topic food, bananas occurs a lot and kale occurs a lot. And that's how you know that that topic is food. Then you have the topic of animals, and you see kittens occurs a lot, puppy and cute occur a lot. Okay, so that makes more sense for animals. So again, the whole idea behind latent Dirichlet allocations is you see everything as a probability distribution. So every document is a distribution of topics, and every topic is a distribution of words. Okay, so how does latent Dirichlet allocation actually work now that we have these probability distributions in mind? Well, let's take an example. So again, our goal is we want LDA to learn about the topic mix in every document and the word mix in each topic. So the first thing we have to do is choose the number of topics we think there are in our corpus. In this first example, where we had food and animals, I chose 2 topics, and that's a pretty standard amount to start with. You can start with 2 topics and then keep increasing it as you go along. So what happens at the very beginning is LDA is going to look at all the words in your corpus, or so all the words in the documents in the corpus, and it's going to randomly assign each word in each document to one of the 2 topics. Okay? So for example, on the top right there, we have our first document, and let's say the word banana in document 1 is going to be randomly assigned to topic B, which is the animal topic. So right now we know that this is incorrect, but it's okay. This is just the first random assignment. Okay, so now what happens is after the random assignments, LDA is going to go through every word and the topic assignment in each document. So what it's going to do is it's going to go through document 1 on the top right. It's going to look at that word banana, for example, and it's going to look at the topic that it was assigned, which was, in this case, was topic B, or animals. And so now it's going to do 2 things. It's going to look at how often this topic occurs in the document, so how often that topic B, animals, occurs in document 1. And it's also going to look at how often the word occurs in the topic overall. So how often does the word bananas occur in the topic B, or topic animals? And we found from the previous slide, not very often, right? Bananas occurs more in the topic food. So based on those 2 things, what it's going to do is it's going to create a new topic assignment for that word bananas. So again, with the bananas example, it looks like animals doesn't occur often in document 1, and banana doesn't occur much in topic B. So what it's going to do is it's going to reassign the topic for bananas. It used to be assigned topic B, now it's going to be assigned topic A, which is food, and that seems like a better assignment. So LDA, again, if you look at the 3rd bullet there, what it does is it randomly assigns each word in the document to one of the 2 topics as a first pass. Then it goes through every word in the whole corpus to see if the topic assignment is correct. And after one iteration of this, you can actually go back and go through a second iteration of checking every word in its topic assignment. And you're going to do that over and over and over again, and eventually the topics will start to make sense. And then it's your job as the human to interpret the topics and figure out what those topics actually represent. So this seems pretty complex, but luckily GenSim does this part for you. So all you need to do is you need to know your goal is to use LDA to do topic modeling. You need to pick your number of topics, and then you have to set your iterations, and you can have LDA run in GenSim. Okay, so let's go through the specifics of what you need to make LDA work. First is you have to specify your inputs. So one is that document term matrix, which I'll show an example of in the Jupyter Notebook. 2 is the number of topics, and 3 is the number of iterations you want it to go through. So what GenSim will do is it goes through the process of going through the entire document, reassigning those topic assignments, and then it's going to find the best word distribution for each topic and topic distribution for each document. So again, what that means is for every topic, it's going to figure out what are the mix of words that are best for that topic. And then for each document, it's going to figure out what's the best mix of topics that make most sense for that document. And then the output to this step is the top words in each topic. So let's say we chose 2 topics for LDA. What's going to happen is it's going to tell me topic 1 is mostly consisting of these words, and then topic 2 mostly consists of these words. And then your job is to figure out if they make sense or not. And if they don't make sense, then there are other parameters that you can alter, and that I'll talk about again in the Jupyter Notebook. And then you know you're done when your topics make sense. So this is a probabilistic approach to topic modeling. There are also a couple of matrix factorization approaches, such as LSI or NMF, that work really well for topic modeling, but we're going to focus on LDA for this demo. Okay, so at this point, I've explained all the theory behind LDA, and I want to show you how it works in practice. So I'm going to go through this Jupyter Notebook, and again, you can find all of my code on GitHub at a dash of data. Okay, so for this topic modeling notebook, what I'm going to do is show you how LDA works, and then also how to tune the parameters. So first, we're just going to go through a very basic LDA model, and you see I've called it Attempt 1 because this is not something that's going to work the first time you do it. You're going to try some parameters. They're not going to work really well, and then you're going to have to keep on tweaking the parameters until it does work well. So first what I'm going to do is I've pickled my document term matrix from an earlier notebook. And again, what pickling means is I've saved that data frame so that I can now read in that data frame in this notebook. And you see this is what my data frame looks like. This is my document term matrix. Every row is a document. In my case, it's a comedian's transcript. And then every column is a term or a word. And then you see all the values in here are word counts. So within Bill's comedy routine, he says ah 1 time, and he says ABCs 1 time, and so on. Okay, I have my document term matrix. So now I'm going to import a couple modules that make LDA work. So we have GenSim, and here's what I'm importing. I'm also importing this function that I'm able to use for sparse matrices. All right, so one of the required inputs, if you remember from what I mentioned before, is a document term matrix. And in fact, what GenSim needs is the transpose of that. So it's a term document matrix. So what I've done here is it's exactly what you saw in the previous picture, but it's been transposed. So now these are all my terms, and these are all my documents. Okay, now what we're going to do is these couple steps here that you would do for every LDA model that you run. So what I'm going to do is I'm going to turn that term document matrix into a sparse matrix, and then I'm going to apply this sparse to matrix function on top of that. And then another thing that GenSim requires is a dictionary of all terms. So what I'm going to do is I'm going to open this file that I've pickled earlier, and what that includes is the whole vocabulary of my corpus. So what are all the unique words in my corpus? I'm going to call that ID to word, and that's something else that I can include in my LDA model. Okay, so now that I've done that, I can put those things into my LDA model. So models.lda model, this is from GenSim, and you can see I've put in a corpus here. So the corpus is my term document matrix. I've put in ID to word, which is the vocabulary of my corpus. I've specified the number of topics. Again, I'm going to start with 2 because that's the simplest thing to do. And then I'm going to specify the number of passes. So if you remember from the theory, what happens is LDA will go through an entire corpus, look at every word, and figure out if the topic assignment for that word is correct or not. And it's going to do all that one time. And then in this case, when I say passes equals 10, it's going to do that 10 times. So the more passes I put it through, the more my topics should make sense. I'm going to start with 10 for now, but you'll see that you can even do 50 or 100 passes to make these topics really solid. So after I run this LDA model, this is what I get. And remember, the output of my LDA model, the first part, the first row here shows me the top words of my first topic, and the words here are the top words of my second topic. So if I take a look at these, they're not telling me too much about the topics that the comedians are talking about. So I'm going to try something else. I'm going to try to up the number of topics to 3 topics and see if they make more sense. Looking here, they don't make too much more sense. And so I'm going to try this for 4 topics. And again, they're not looking that great. So instead of just modifying this number of topics parameter, I'm going to try modifying some other parameters as well. So here's my attempt 2 section. Instead of looking at all the text in my corpus, what I'm going to do now is look at only nouns. And so the way to do this is I can use NLTK. And NLTK is another library that has a lot of NLP text pre-processing techniques incorporated into it. One of them is this parts of speech tag. So what you can do is you can take a look at all your text and then figure out which words are nouns, for example, which is what I'm doing here. So with parts of speech, I can figure out which of my words are nouns. And what I'm going to do is I'm going to take all my data right here, and I'm going to filter it down so that only the nouns remain. And now that I have only the nouns, I am going to recreate my document term matrix here. So you see here are all of my documents, here are all of my terms. It sees these as nouns, and which NLTK is not always perfect, but in this case we'll let it slide. We sees all these as nouns, and then this is a new document term matrix. Okay, so now that my corpus only contains nouns, we can go through LDA all over again. I'm regenerating my GenSim corpus and my vocabulary, and now I'm going to do LDA with corpus just including nouns. And then here's my vocabulary just including nouns, starting with 2 topics and 10 passes. And you see the words in the 2 topics are starting to make a little bit more sense, but they're not great. So I'm going to increase this to 3. They're still just okay. I'm going to increase this to 4. Again, these are still just okay. So what I'm going to do, I'm going to do another attempt. Instead of just doing nouns, I'm going to look at nouns and adjectives. And this is a popular way to fine-tune your topics, is looking at nouns and adjectives. So what I'm doing here is I'm saying, show me all the nouns, and then show me all the adjectives. And the way I know what a noun and an adjective is if you look above here, all of this, all the word tags are actually from University of Pennsylvania. So if you click this link here, then it tells you that NN means nouns and JJ means adjectives. All right, so now what we're going to do is filter our data so that it includes nouns and adjectives. And then we're going to recreate that document term matrix to include nouns and adjectives. We're going to redo everything again. So regenerating the corpus and the dictionary for GenSim. And now my corpus includes nouns and adjectives. Vocabulary is nouns and adjectives. I'm going to start with 2 topics. And now these are looking pretty good. You can see that the topics are actually pulling out distinct themes in the data set. So at the very end here, I have 4 topics. And topic modeling takes a while. When I was doing this exercise, this took me about half a day to really fine-tune the topics and figure out what to do. But let's say we're just gonna go with these 4 topics here for now, because they're looking pretty different. And so far in this exercise, I've done 9 different topic models, and the last one I think makes the most sense, the one that has nouns and adjectives and it's 4 topics. And so what I'm going to do is I'm going to rerun that one more time. So remember, this is nouns and adjectives, 4 topics, and I'm going to increase the number of passes. And what increasing the number of passes does is it really stabilizes which words fall into those topics. And then you see these are my 4 topics. So let's interpret them. So if I look at this first one, it seems to be about moms and parents and family members, I would guess. This next one, you'd see like talk about husbands and wives, okay, spouses. This next one is about guns. And then this last one is just profanity. And so these, I would say, are the 4 topics that all the comedians are talking about. And another thing you can do with GenSim is, now that you've figured out what the topics are, so for every topic, what is the word distribution in that topic, or what is the mix of words in that topic? What you can also do is, for every document, so in this case, every document is a different comedian's comedy routine. For every document, you can see what is the mix of topics in that document, or what is the topic distribution for that document. So for Ali Wong, in her routine, she seems to talk most about topic 1, husbands and wives. And you can see John Mulaney and Michael Birbiglia also talk about husbands and wives. Okay? And here in this case, I've just shown you for every comedy routine, for every document, what the top topic is. But every document can actually be a mix of topics. And so one document could be maybe like 50% about moms and parents and 50% about husbands and wives. And that would, you would be able to see that using this code here as well. All right, so after the first pass of LDA, these are my topics, and for every comedian, we see what topics they tend to talk about. Here are some additional exercises. This was my talk on topic modeling, and next I'll be talking about text generation.